In this video, we're going to look at the distribution of the sample proportion, and we're actually just going to do some examples. So from before, we had our definition of our sample proportion, so we're going to review that and then look at a few examples and really dive into that material. So first of all, we need to remember that the shape of the sampling distribution of p hat, which is our sample proportion, is approximately normal if n times p times 1 minus p is greater than or equal to 10. So we're going to have to check this before we do examples. The other thing that we need to remember is the mean, mu sub p hat, is just p, and the standard deviation, sigma sub p hat, is the square root of p times 1 minus p over n. And then the last thing for calculating probabilities is our z-score right here. And our z-score is always our data minus the mean over the standard deviation. In this case, our data will give us our sample proportion minus our mean, which is mu sub p hat, and then divided by our sigma sub p hat. So if we translate everything into our equivalent formulas here, we've got our p hat, which is our data, minus the mean, which we saw up here was just p, and then we substituted in this square root for our standard deviation. Okay, so let's look at an example. According to credit.com, 29% of adults do not own a credit card. So part A, suppose a random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution of p hat. Okay, so first thing, before we even answer the question, there's a couple pieces of information in our example. We know that p is 0.29 because that was our percentage of the population that do not own a credit card. And then in part A, they gave us the n, which was 500. So let's go ahead and reread what they want. It says, describe the sampling distribution of p hat. Okay, so from before, we need to check that it's approximately normal. That way, if we do any other questions, we already know that we can use that normal approximation and draw that nice bell curve. So plugging in, we've got our n, p, 1 minus p, and we're going to ask, is that greater than or equal to 10? Okay, so using your calculator, we can see that this multiplied all together gives us 102.95, and that is definitely greater than 10. So that checks out, and it's approximately normal. If it had said that it was normal in our example, we wouldn't have to check this, but because it didn't, it's really a good idea to do that. Okay, so now we're going to describe the sampling distribution of p hat. So describing it just means get your mean, which is mu sub p hat, which is 0.29 because that's just p, which we found up here, that was given. And then our sigma sub p hat is going to be a little bit more complicated just because we have to plug this into a formula. So we're going to plug in p and then do 1 minus p over n. Plugging that in, we get 0.29 times 1 minus 0.29 over 500. If we use our calculator over here, we can plug this in. We just have to be a little bit careful with parentheses. So let's do square root of, and notice it brings a little box under here. So I'm going to put 0.29, but I want to make sure that the entire numerator here shows up as the numerator here. So I'm going to put an extra set of parentheses. And I'm going to do 0.29 times, so I'll put an open parenthesis just like I see over here, 1 minus 0.29, close that parenthesis, close it again because now we've encapsulated the entire numerator, and then divide by 500. Okay, so we get on our calculator 0.02029. So if we were to round this to 4 decimals, we would get 0.0203. So let's go ahead and put that here. Okay, so that's actually all we have to do for describing the sampling distribution of p hat. We just have to state our mean and our standard deviation. The mean is pretty simple because it's just p, which we had, and then the standard deviation, we had to do a little bit of calculations in our calculator. Okay, so so let's look at this next example. We still have the 29% of adults who do not own a credit card. This time they're asking, what is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So from before, let's go ahead and put what we know. So we know that our P is 0.29. They gave us our N, which was 500. And then in this case, they give us our P hat already here, which is 0.30. So this comes from a random sample of the 500 adults. That's our sample proportion. Okay, so we want a probability this time that more than 30% do not own a credit card. So if we write that in mathematical notation, we have big P for probability, and we want the probability that our P hat is greater than 30. Since it just said more than, I'm not going to put greater than or equal to. Okay, so unfortunately, P hat is just a little start. In order to calculate probability, we have to find that z-score. So I'm going to rewrite that z-score formula here, and we're going to plug in everything. So our P hat was 0.30, our P was 0.29, and then we plug in here. Again, we're going to do this in our calculator, and we get 0.49. So we actually get more decimals, but I'm just rounding to 2 decimals because our z-score chart only goes to 2 decimals, so that's really all we need. So now up here, instead of the probability of P hat being greater than 30, or 0.30, we really want to look up the probability that Z is greater than 0.4928, or again, just 0.49. We really only need those 2 decimals, so round up or down depending on what those decimals are. Okay, so let's go ahead and draw a nice little bell curve. We'll mark that area of 0.4928. Again, we're just going to look at 0.49 on the z-score chart. We want more than, so I've shaded area to the right. And then if I look at the z-score chart, notice that this doesn't give us that tail end area that is actually on our picture. So what we're going to do is we're going to look up 0.49 on our z-score chart, and we're really going to take the entire right half, which is 0.5 or 50%, and then we're going to subtract off this middle area. So let's go ahead. 0.49, so we go 0.4, and then go all the way over to the 9, and we get 0.1879. Again, remember, we're going to subtract that from the entire half, which is 0.5. So we've got 0.5 minus 0.1879 that we got from our chart. And then if I subtract those, we get 0.3121. Okay, part C, we still have our 29% of adults who do not own a credit card. This time they're asking, what is the probability that in a random sample of 500 adults, between 25% and 30% do not own a credit card? So just like before, we are going to state what we already know. We still have the P equals 0.29, our N is still 500, and our P hat is 0.30, but then again, we have this extra P hat here, which is 0.25 or 25%. So really when we write our notation here, we want the probability, so it says capital P, that our P hat is in between our two numbers, 0.25 and 0.30. So we have to convert both of these to z-scores. So let's go ahead and do the 0.25. So there's our z-score formula, or data minus mean over standard deviation. Plugging in our 0.25 here. Remember, the 0.29 is going to be seen everywhere where P is, so that's never going to change. And plugging that in, we get a z-score of negative 1.97. Now, luckily, we just did the 0.30, so I'll go ahead and just put that on the screen. For 0.30, our z-score was 0.49. So let's go ahead and graph this again. So we can get our area, the probability that z is in between these two z-scores. And we see here that we've got a z-score of negative, so it's going to be to the left of 0 on the number line, and then we've got our positive z-score for 0.30, which is going to be to the right of 0. So here we want all this area in between. Okay, so nice thing, if we go to our z-score chart, it's giving us area in between. So really we want the area in between 0 all the way up to 0.49, and then we want 0 all the way back to negative 1.97. Now remember, this is symmetrical, so I'm going to look up the 0.49 and just a positive 1.97, and that's going to give us the identical area on the left. So 0.49 again was 0.1879, and then 1.97, again it's symmetrical, so I'm looking up the positive, so I'm going to go 1.9 all the way over to 7, and it looks like 0.4756. And because these are both in between areas, we're going to add them together. So we get our 0.4756 from our negative 1.97, and then we get our 0.1879 for the area between 0 and 0.49. Okay, add those up, and we get our probability of 0.6635. Okay, one last question here. We've still got our 29% of adults who do not own a credit card, but now we're going to ask a little bit different type of language here. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? So for this one, we've got our P is 0.29. They actually give us the X here and the N. And we know that we can calculate the p hat as x divided by n, so I put in the 125 divided by 500, and that gives us 0.25. Okay, so let's write down what we want. We want the probability that our p hat is less than or equal to, because it said 125 or fewer, so that means we include 0.25. Okay, good news, we just did 0.25, so let me put that up on the screen. We calculated our z-score for p hat at 0.25 to be negative 1.97. So let me go ahead and put that up. So we're looking at the probability that z is less than or equal to negative 1.97. Let's draw our curve here. Again, we're looking at tail area. So when we go to our z-score chart, we're going to use that symmetry, meaning I can look up the positive, but because we want the tail, we're going to take 0.5 and subtract off whatever we find from our chart. So just going back to 1.97, so we're going to take half of our area, which is 0.5, and we're going to subtract off 0.4756, and that's what I got from our z-score chart. Okay, calculating that, and we've got 0.0244. Now, it didn't ask us for the probability. It asked us, would it be unusual? So unusual is probability, but unusual is a specific type of probability. So remember that unusual means that our probability is less than 5%. So in this case, since our probability was 0.02, which is definitely less than 5% or 0.05, this is considered unusual.